Hi everybody, my name is Yalda and I'm a Swartworth student. Today I'm going to be your YouTube guide.
So, just really quickly again, so the pressure you feel is external pressure plus rho GH, where rho is always of the fluid, right? And just to show you really quickly, not that important so you believe it, everything does work out, the units really are pressure. It's very mellow because, you know, density is mass over volume, you know, G is G, and then H is obviously H, right? But G is an acceleration, so you can think of this as acceleration. Then you have mass times acceleration, but you know mass times acceleration is a force, right? So this is basically newtons, right? And then what do you have left over? Volume over H. Volume is cubic meters. Height would be in meters. It would cancel and give you newtons per square meter. That is force per unit area. That really is pressure. Okay, so let's send this away. Now let's try a quick problem with this. So we'll start with the mellow problem. This is supposed to be a uniform U-tube. My bad. The diameters are supposed to be the same, but it doesn't really matter. So let's say we have on this side some liquid, on this side another one. Let's say oil on this side, and let's say water on this side. And let's say I tell you that the density of the oil is 1/3 the density of the water. Okay, so no big deal. And then I also tell you, let's pick a line like here. We're going to measure from this point. Let's say I tell you this is 10 centimeters. I would like you to tell me what this height is. Okay, so not that bad, just a little bit of practice. So let's set this up. First, conceptually. At this line, oh, by the way, and the dividing line's right there. Okay? At this level, the pressure being exerted by the water must be exactly equal to the pressure being exerted by the oil. If it weren't, let's say the water were greater, the pressure from the water was greater, then the water would push, the oil would push, the water would win, and this guy would be shoved up this way. Okay? But at this point, everything's in equilibrium. The water isn't moving, everything's still, right? So you know the pressure along this line must be the same. Okay, so let's compute that. Pressure from the water is going to be rho naught plus rho GH, H going for the height of the water, density of the water, remember it's always in terms of the fluid, right? Over on this side, what about the oil? Pressure for the oil should be pressure atmospheric again plus rho of the oil, G height of the oil. Do you guys agree with this? Okay. And at this point, they must be equal. So let's go ahead and set them to be equal. Sorry, I'm going to have to erase part of the picture. Okay, so now we have that guy over there. So atmospheric plus rho water, G height of water is equal to atmospheric plus rho oil, G height of oil. Okay, so no big deal. In fact, just in case your professors like to do things in general, I'm going to solve this in general, and then we're going to plug in the numbers. Okay, so rho naught will die from both sides, right? Because the atmosphere is pushing down both sides equally. Okay, I know technically if you're being really anal about it, the atmospheric pressures wouldn't be exactly the same because they're not the same level. One's lower, the other is a little bit higher, but we won't have to worry about that. You can assume from, unless there's a big change in height, that atmospheric pressure is pretty much constant. Okay? So, let's start with this. Again, make your life easy, pull that retarded G. Okay? Now we have rho of the water times height of the water is equal to rho of the oil times height of the oil. Okay, no big deal. We're solving for, I guess we're trying to solve for height of the oil, right? Okay, so let's try to figure this out. Then let's write this up. It's rho of the water over rho of the oil times height of the water is height of the oil. Almost done. We're going for this. They told us what this is, and you know what this ratio is. In fact, let's just plug in. You know the height of the rho of the oil is 1/3 the rho of the water. So rho of water over 1/3 the rho of the water, just substituting in here like this, times the height of the water is the height of the oil, right? These guys will kill each other. That's 1/3. The 3 is going to flip up top. So we get 3 times the height of the water is equal to the height of the oil. Okay? And plugging in at the end, that means 3 times the height of the water, which is 10 centimeters, is equal to the height of the oil, which means the height of the oil is 30 centimeters. That totally makes sense. Since the water is denser, right? Because the oil is 1/3 of the water is denser, it pushes down more, right? Per unit volume, right? Which means it's going to shove down more, so you need more oil to make up for that. So it totally makes sense that in this U-tube, oops, close enough. That you have a ton of oil and not as much water.
I don't know about you guys, but I'm going out to lunch. See ya.